Hi, everybody. Here's a video which has to do with the WT4. And, so we have here a triangle. Now, by the way, all these triangles, if I was good at this, all these triangles, the base would be flat. All these triangles would be congruent. They'd be just equilateral triangles. They'll all, and the base would be flat. But I am not the best at being an artist. So, so you have to bear like this one here is pretty messed up, but they're all supposed to be just flat and the same and so forth. Anyway, that being said, there's 6 things you could do to a triangle and still preserve position, meaning that you'll do these operations and they'll still be, and the triangle will be back in the same position it was in. It'll occupy the same space. So I could do 0 degrees, which means I'm just leaving it alone. I can rotate it 180 degrees, 120 degrees. And if I do that, this vertex that B is going to be up on top. The A is going to go down there, and the C is going to move over, to the left. So I have a B up on top, the A will be down there, and the C will be on the left. If I rotate this 240 degrees in that same direction, then I'm going to wind up getting the C on top, the A on the left over here, and the B on the right. Just that's what I got. Now, those are the first 3 things I could do. The second 3 things I could do is that I can, oh, you know what? Let me just show you how handsome I am. Okay, I just want you to know I'm really here. It's a ghost speaking to you, but it's actually I'm right here. I'm a human being. Anyways, this can flip it around its axis. So here, here's our triangle, our starting triangle. We're taking this, imagine if you have a piece of paper and I don't know if you can see it. Oh, you can't even see it because of the screen. But you're taking it and you're flipping. Now, when you flip it around, what's going to happen is that the top guy is going to stay the same. They're going to switch with each other. So I have the A still will be on top, but the C is over there now, and the B is on the right. Now I could also flip it around this other axis, the right axis. So this is the top axis. That's the right vertex, and that's the left vertex. That's how I'm going to refer to these. I could have called, instead of F1, F2, F3, I could have called it FT for top, R for right, and FL for left, but either way. Anyway, I could take this original triangle and I could flip it a right vertex. So what's going to happen is that the vertex on the right, the C, is going to stay the same, but the A and the B are going to flip. They're going to switch positions. And I'm going to get this. I'm going to get a B on top, an A on the left, and a C here on the right. And finally, I could flip it around the right, bottom vertex, and which means that the B, which means that B is going to stay put, but the A and the C are going to wind up flipping over. And that's actually, I can get my hand, but I can't get this piece of paper. That's weird. That is very weird. Okay. Anyways, and then I wind up with the B on the left and the A and the C. Okay, so it turns out that these, if you can consider these to be operations on an equilateral triangle, if you view these as operations, if you view these operations as, you can view these operations, I could view this as the elements of a set of operations. So I could take these 6 operations and put them in a set, and I have a set now of these 6 operations. Well, guess what? Turns out that these operations form a, that's right, you heard me. These operations form a group. So let's see how this works. Let's see, how are we going to show this? So first of all, I made a table here. That's just the ops. I'm running ops. Oops. Ops. I think I want to make it bold. All right. So these are the ops. So my options are, as I said, 0, 120, 240. Okay. Now in this the way I'm setting this up, that this is here on the left is the thing I do first, and on the right is anything I do second. It doesn't have to be that way. Just be clear. So the left is what I'm doing first, and the top is last. So um, if I do a 0, so notice that 0 is the identity element, because basically, if it's already, if I do 0 and then I do any of these operations, it just becomes that second operation. If I do any of these guys, if I do any of these guys first, and then I do 0, it just stays again. It just stays like that. And notice that the inverse of 0 is itself. The inverse of 120 is 240. Because if we do a 120, then a 240, that gives me, or a 40, then a 120, that puts me back to the 0 position. And notice that down here, the F1 is its own inverse, which makes sense. If I have something, I flip it once and I flip it, I get back to the same thing I started. F2 is its own inverse, and F3 is its own inverse. Now, it may not be commutative. In fact, I'm going to show you right now that it's not commutative, because I'm going to fill in some of the other. Notice I didn't fill in the entire table for you. I want you to do some of the work yourself. So let's take a look. Let's first do rotation followed by an F1 flip. So what's going to happen when I do that? So 120 rotation followed by an F1 flip. So I start from scratch. Rotation, that puts me here. The B is on top, and then the C and the A. Now I'm leaving the B on top, and I'm doing a flip on the top through the top vertex. So this A will be here and the C will be there. Well, guess what? That's the same thing as F2. So if I start with a 120-degree thingy ding, and then I follow that with an F, that's the same as if it was F2. Start with a F1, and then what if I F1, and then do a 120-degree flip? Will that also be an F2? Maybe it will, maybe it won't. Remember, these groups don't have to be commutative, and this thing may or may not. So let's just take a look. If I start with a F1 flip, so again, this is my starting position right here, but I'm doing an F1 flip, and that gets me down over here. Now I'm rotating at 120 degrees. And by the way, if you notice, our clockwise I'm rotating, which may or may not, I don't know if that's the best way to rotate it up, it doesn't matter. It just pick something and stick with it. So what happens now is that this A is going to wind up over here, B will wind up over there, and the C will wind up on top, which is the same, by the way, as F3. So if I first do an F1, then follow that with a 120, I wind up getting this position is the same as F3. So let me boing, type F3. So if you notice, this is not commutative. This is not commutative. Now, if I do, so what your mission, should you decide to accept it, is to fill out this whole table and doing your various flips and rotations. And then after you've done that, that's the interesting, that's one part. But then what you do is what you're going to need to do is to show that what you have has the group properties. Show that now the group properties. Funny you should ask. Well, if you just look at our textbook, we'll see that right now. Oh, actually, I think it might even be in the. I didn't have to go to this. I think I put the group definition here somewhere. But I put some of the jokes. Some of the jokes that I liked, I put in the. What did it? I thought I thought I put the definition of a group in here. Maybe I didn't. But I did. Maybe I just didn't bother because it's right there in the textbook view. All right. Well, this has been a nice waste of time. Scrolling around, getting nothing. So let me let's go to our textbook, and there you go. Discrete structure there, and structures. Much. Let's move that also. Maybe. Let's see. I'm going to put this into the thing. So, definition of a group. The nice thing I have, but the definition, as you're going to see, is going to be identity, inverses, and associativity. What is the definition of a group? I just this is something I do not like, is wasting everybody's time. Here we go. Here's the definition of a group. I'm going to take that and I'm going to put that. I'm going to snip this and put in. I'm going to put the definition of a group into the. This is so again. It's not that hard. It's just that there's an associative operation, and there is this identity. Now, by the way, the operations, we're using two words here. The operation, see, these things are operations on a triangle. Operation in the group is just doing one followed by the other. That's the whole operation. It's doing one thing, then doing the next thing. Because I'm using the word operation in sort of ways. The elements of the group are not operations of the group. The elements of the group here are operations on a triangle. But these operations on a triangle, if I view them as being elements, and I just doing them consecutively, that's my operation. Anyways, so the operation is associative. Now you're gonna have to show that. There exists an identity element that we saw right away. It was easy. There exists inverses for every element that you could really easily see from the table. So what you're gonna have to do is fit the whole table and then show that it's associative. And you may have to show it if you have a slick, elegant way of showing it. That would be great. If you have go try all the different possibilities and show that no matter how you, whatever way you want to do it, that's really what you're gonna have to do. So let me just copy this in here and put this into our chat. I just think it's nice to have that in the. I just want to have it in. I mean, you could always look it up in the thing. It's nice to have it accessible. So there you go. That is your mission. Should you decide to accept it, that is what you're going to need to do for WT4. Have fun with that, and we'll see you guys next time. Back video, and bye everybody.